So my project is Beyond the Census, identifying and mapping women's work in 1911 Charlotte. And so I utilized a couple different methods here. I utilized the extracted Charlotte data set. I also utilized Google Map of Charlotte, the OpenStreetMap of Charlotte, as well as the 1911 Charlotte Census. And then the tools I utilized were Excel, OpenRefine, Tableau, and QGIS. In doing this, because I had such a broad range of tools that I was utilizing, I covered a lot of different computational thinking methods. And so for data practices, I covered manipulating data, creating data, analyzing data, visualizing data. For modeling and simulation practices, I covered using computational models to understand a concept, using computational models to find and test solutions. And for computational problem-solving practices, I covered preparing problems for computational solutions, assessing different approaches and solutions to a problem, troubleshooting and debugging, which unfortunately ran into a couple times. Never like to see that. And then I also covered under system thinking practices, understanding relationships within systems, thinking in levels, and communicating information about a system. So for the overview of my project, I really wanted to work to identify and uncover different jobs held by women in the workforce in 1911 Charlotte. And I kind of wanted to be able to explore that data a little bit further through the nuances of marital status and race. And I really also want to contextualize that by understanding women's mobility at that time. So my final goal was to create maps of different women's commutes from Charlotte, from their home to their workplace, just to kind of get a visualization and an understanding of what it was like to not only be working and the types of jobs they worked, but also what their daily lives were like. So that was a really goal here. My objectives were to identify the top jobs held by women in 1911 Charlotte, create an accurate map of some of these women's commutes and the time committed to their daily commute, and identify all women in the 1911 Charlotte dataset using accessible data manipulation tools. So I'm going to go into my data manipulation. So for data manipulation, I utilized OpenRefine and Excel to add a column for gender and identity and assign all rows so that all data set can be used to examine the nuances between labor and gender. And in doing this, I utilized the consolidated Excel file for the Charlotte 1911 city directory. In OpenRefine, I started by doing some general data cleaning, but I really started by creating gender. So that was the first column I wanted to create. I did this by identifying a column which I knew was really only used to identify women. And so that would be the married column. And in this column, we only see two values entered, and that was Miss or Mrs. And so in doing this, all I really had to do was identify if there was any text entered in that column, and then I can safely identify that that was a woman. So that one was very easy to get off right off the bat, and knocked out a large amount, 2,000 rows for me. So that was very helpful. I then wanted to separate name columns because I knew later on down the line I was going to be working with names to identify women in the data set. So I separated that into 3 columns: first name, last name, and middle name, just so that I would be able to search by first name and kind of use that as a way to identify women. I then wanted to clean up the job data. And so I went through and I cleaned all abbreviations, just so that when I was looking at this data, it would be more understandable and comprehensible, just to be able to further understand this data set with ease and not to be confused with other jobs and the like. So that was helpful. I then went into truly identifying the gender. So now that I had the gender column defined, and I cleaned up the data a little bit, I started by creating different filters to separate gender. And so I started by creating a filter for the spouse column. And if there was a spouse entered, similar to the married column, if there was someone entered for a spouse, it was largely identifying that there was a wife to a man that was entered in the data set. And so I could safely assume again that anyone who had text in the spouse column was a man. So that again was a really big chunk of data, which was helpful to have. And then I also did the same thing for the widow comment, which if there was any text entered there, I could know that they were indicated as being a woman. So again, really helpful to knock that out. And that really helped clean up a lot of the data and help me identify a lot of the people in that data set. And so then I moved into filtering based on common names. And so here I was looking based on common names. So names like Jane, John, filtering for those names and then flagging them dependent on the name. And again, this is something that could be, and I think Frank pointed this out, a little bit more convoluted, especially when we're talking about a data set from 1911. They use names that we don't commonly use now. And they also had names were used differently then. And so someone who I might think of Ashley one way or the other, Ashley might have been used differently back then. So that was something I had to keep in mind. And I did utilize ChatGPT and Google just to kind of see how those names were commonly used at the time. And that helped me clear that up a lot. So in doing so, I would just search for the name in the filter, and then I would go ahead and transform that based on the value that I decided should be inputted there. But unfortunately, as mentioned, due to the nature of names, this did not catch every single individual. There were still a lot of people who were not caught in these large filters. And also there were some differences in spelling. There were some names that were only entered once, spelled a very specific way. So once I got down to around 1,000 entries, I went through and manually identified the remaining entries, again, verifying via Google and ChatGPT just to verify that how that name was commonly used. But for some of them, they were easy. It was just a different spelling. And then the last bit of data manipulation I did was creating CSV files for QGIS. So knowing that in data visualization, I wanted to be working on creating maps of the different locations. I did want to create individual CSV files for the 3 women whose commutes I would be mapping. So I went ahead and did that as well. So I would identify that individual's location. I would identify that latitude and longitude, so based on their home address. And then if they had a place of work listed, I would identify that place of work's address using the business directory. And again, I would identify that latitude and longitude. And then I also do have my JSON file here for reference if anyone ever wants to look at that. So I'm going to go into visualization. So for data visualization, I utilize 2 tools, as I previously mentioned, Tableau and QGIS. So starting with Tableau, I did get to work with this a lot. There's a lot of different variables I could have worked with here. But I did want to kick off by just kind of getting a general count of jobs and looking it up by gender so I can understand what I particularly would be digging into. So we can see a distribution of gender, which was really interesting to see. And then I got to go into a little bit more detail by looking at top counts. So I really wanted to see what were the specific jobs that people were working. So I did some visualization with that. I primarily utilized bar charts, pie charts, and tree maps, which you can see here. And just working with different categorizations and different ways of mapping this out. So I just wanted to see what I can really find. I wanted to really dig into the exploratory data analysis. And there was a lot to be seen. So as I will get into once I get into my conclusions. But for QGIS, I actually wanted to figure out, so I really wanted to get that commute down and I wanted to get that route mapped, but I also wanted to see if I could find a commute time. And so with QGIS, there is a plugin called Travel Time, which is really neat. If you plan on working further with QGIS, I highly recommend it. It was really fun to use. It's really interesting to use. And it's really easy to use as well. So I would take my CSV file that I had previously created, enter that in here. I would mark their home address and their work address, and then I would utilize the travel time tool to mark their home address and route it to their work address. And you're able to use this plugin to track also public transportation, cars, buses, things such as that. But due to the time period of this data set, I figured the most accurate way to do this would be to use walking. I know there were other ways to travel at the time, but again, obviously cars were not commonly used at the time. I'm not sure if there was a trolley map at the time, and if so, how that would have been used. So I primarily utilized walking. I figured it was most cost effective and it was the equalizer. So I figured it made the most sense. So in doing this, I was actually able to find their routes and identify that. And with this plugin, you're able to actually get directions for the route as well, which is really interesting to see. You're also able to get the distance as well as the travel time. So that was really, really helpful. And I'll get to dive into that with analysis. Going to analysis, here's the summary of my findings. I'm going to start by going into my Tableau. I got to get some really interesting data here. I'm actually going to scroll back, keeps kicking me down to the end, but found an interesting graph. I'm going to start by looking at the distribution of employment by gender. And so this is something I pointed out earlier. I had found and looked at just what the counts were and what kind of numbers we were looking at when we were thinking about how gender was divided based on employment. And so when we're looking at people who are employed, the highest number is men at 8,805 jobs, and women had 1,711 jobs. We do have a pretty high null category as well. Those are just people who I was not able to identify based on gender. But we do still have a really high count of women. But then when we go into distribution of unemployment by gender, and this is not necessarily unemployment, but it's just people who do not have a job entered. So that's just a null status. We have women at the highest count with 2,710, whereas men, there's only 915 who do not have a job entered. So kind of interesting to get to see that. But I really wanted to see what the top 20 jobs were held by women at the time. I thought this was really interesting to see, just kind of get that laid out. But I was really shocked to see, I had kind of come into this with a bias, expecting it to be a lot of different types of domestic jobs. Or I did expect clerk, but I honestly was not expecting stenographer. But that was actually the highest job for women at 246. And that was really shocking to see. So that was really interesting. Of this, we get to see a lot of different jobs kind of mapped out here. We have clerk, mill worker, teacher, laundress, student, nurse, cook, seamstress, domestic, works, dressmaker, madam, boarding, cashier, operator, bookkeeper, milliner, sales lady, and employment. So a really interesting distribution. Definitely not what I would have expected right off the bat when I was looking at the different jobs that are held there, but I think it was very interesting to see. So I then wanted to see what the distribution of employment was based on marital status. I was kind of interested to see, well, what types of women were working at the time? Were they married? Were they not married? Or was there just nothing listed? And we have a really high count of unmarried women working at 1,147. We also have a really high count of null women working at 470, but very, very low counts of women who are married working, and only 94. That does bring into question how accurate this null is and who is missing from this. And so I really do think we have to question what women were not accounted for, their marital status, one way or the other, because I imagine that this is not a truly accurate number. But unfortunately, due to the data set, there's not really a way to tell one way or the other. So then I'm going to go into the top 20 jobs held by women filtered by marriage status. And I thought this was incredibly interesting. So we're going to have this light pink, which is going to be null, the darker pink, which is miss, and then the darkest pink, which is misses. And you really see an interesting distribution here. I was very fascinated by how high stenographer was for unmarried women. But I was really, really interested to see that laundress was the highest number of nulls. There was no accounting for their marital status. And for those who haven't seen the data set, and I know there are people here who haven't seen the data set today, that is because white women were not accounted for by Miss or Mrs. And so I think what we saw earlier that there is and what I will get into further is that there is a high number, an entire account of Black women working as laundress. That number is not accounted for, and so they are not accounted for by marital status. So I then want to get into distribution of employment for women by race. And so there is this kind of brings into question how accurate this census data was and who it was counting for. Because this does not seem accurate to me. I do think that there are some silences here. I think that we are missing some data as well. But for Black women, we have 358 total women who are working. And for white women, we have 1,353. But I think we're missing a lot of numbers, which is very unfortunate. I think that we're missing a lot of women from the census data. But I then wanted to get into the top 10 jobs held by white women. So just so we can kind of get to see how that was a little bit further distributed and broken down, because there's clearly a difference in when we're looking at who held what type of jobs. So for stenographer, we have 246. For clerk, we have 218. For mill worker, we have 135. For teacher, we have 108. For student, we have 106. For nurse, we have 88. Seamstress, 49. Madam, 29. Cashier, 27. And dressmaker, 27. And then if we get into the top 10 jobs held by Black women, we're able to see that there are 113 Black women who are laundress. We have 67 who are cooks, 46 domestic, 26 teacher, 16 works, 10 clerks, 10 laborers, 10 maids, 8 nurses, and 6 eating house. So we kind of see that broken down a little bit further just to see the differences in those jobs. But I was really interested to see how that was kind of broken up when I looked at jobs that they did have in common. So I pulled teacher and clerk as well as nurse, because those were both jobs that they held as the 10 most common. And I also pulled laundress and stenographer because I really wanted to dive into what that distribution looked like a little bit more at a whole scale. And I found some really interesting distributions here. And we kind of can see where that null status was for marital status, and that missing data that was just not accounted for at the time. So that was definitely interesting to see. Now that I've gone into that, I do want to get into the maps that I developed. So I created 3 different maps. I created a map for Susan Barrington, her commute to work, and she was a stenographer. And she was traveling from her home address to her work address, and it was a total of 27 minutes. I was really excited to kind of get to see this data laid out and just kind of see what that map looked like. But she was a stenographer, had a pretty long walk. It was kind of interesting to just think about what that walk was like every day for her. I have 2 more maps to go through. So Louise Hoskins and her commute to work was relatively shorter. And so Louise Hoskins was a clerk, and her commute from home to work was only 13 minutes, so significantly shorter. And the last map I want to go over is of Georgia Lander's commute, and her commute was comparable at 23 minutes from work to home, and she worked as a teacher. So that was very interesting to see and kind of get into. And it did make me think about not only are people limited based on the jobs that they can get or the jobs that they want to apply for, but also they are limited by their ability to get there. And it definitely made me think about that a little bit further. And I think this is something that people can kind of dive into on a deeper level, just to kind of think about the limitations of transportation and mobility, specifically when you consider location. So that was definitely something I wanted to